Hey everyone, welcome to the Introduction to Alteryx course. So in this lesson, we'll be covering how to set up Alteryx on your system for the first time. So I'm guessing most of us haven't installed Alteryx before. So as you can see here, I've got the Alteryx web page open, or rather the download page open. It's alteryx.com/resources/product support/download Alteryx. I'll share the link as well in the lesson below. So here there are two options. One is for existing customers. For those who have already installed Alteryx, they can choose to upgrade their version to a fuller one. Or if you're new to Alteryx, which I'm guessing most of us are, you can try Alteryx Designer for free. So if you click this link, it should take you to this page. So here you have two options rather. So one is if you're a professional and you're learning Alteryx, you get a trial period of about 3 weeks to a month, I think. Yeah, it's 1 month of analytics for free. Yeah, so it's 1 month of license. If you're a student or educator, you can fill up a separate form and you get a longer period of time to try out the application. But this version pretty much includes most of the features that we would be using or we would be needing for running some data-driven analytics and learning about the tool itself. So go ahead, fill up the form and download Alteryx onto your systems. See you in the next lecture. Hey everyone, welcome back. So in this lecture, we'll cover another question based on the same data set. So we'll find out who the most profitable customer is for the company and which segment they belong to and what product they've ordered the most. So again, we have all of this information in the data set. We have the customer name here. We also have the product ID is here, product name is here, and we also have the category. Yeah. So again, we'll import the data set. We'll use a summarize tool to find out. So we group by customer name and we sum profits because we want to find out who the most profitable customer is. So again, going by the name, sum of profits. And then we sort them by descending order. By the way, the sort tool is available with preparation tab. You should find it here. Yeah. So this is the sort tool. So we are sorting sum of profit by in descending order. And then again, we're using a summarize tool and we find out the first occurrence. So when you sort them, you get the list of all customer names and their profits, corresponding profits. And you want the first occurrence, which is basically the most profitable customer. So in summarize, you have this action called first, last, and so on. So we'll pick first because we've already sorted in descending order. Next, we want to group the customer name with the parent data set and find out the product. So we are going to find out category and product name, both of the questions, right? So segment and product. So you do a join and a browse button to find out what the results are. So I'll run this workflow now and we'll see the results. Yeah. So the most profitable customer is Tamara Chand, but actually let's go one by one. So first we have the input and then we have the customer names. So all of the customer names, there's about 793 records. And we have the sum of profits. Next, we are summing the profits. Sorry, not summing, but arranging them in descending order. So Tamara Chand is the most profitable customer, followed by Raymond, Sanjit, and so on. Next, we're grouping and finding out the first, not grouping, but finding out the first customer. In this case, it's Tamara Chand. Again, we'll run a join to find out which products she's ordered and which segment do they belong to. And as you can see here, it's mostly supplies and technology. Both of them are very profitable segments. We covered this in the last question also. So supplies and technology seem to be the most profitable segments of the company. Whereas furniture is just a big volume business, but doesn't make much money for the company. And again, we can see that the most profitable customers are actually from the most profitable segments that the company operates in. So see you in the next lecture. Hey everyone, welcome back. So in this lecture, we'll be covering month-on-month sales figures based on segment as well as region. That's our question. So again, we'll use the Superstore dataset and we'll use a formula to find out, to extract just the month from the dataset. So if we look at the dataset, we have order date here, which is in year, month, and date format. And we just want to find out the month-on-month sales, right? So for that, we just need to extract the month out of the dataset. Sorry, out of the date column. And that's a first step. And then we use a formula tool here. The formula tool is available inside the preparation tab. And this is the one. And we're referencing order date. Order date is, which I just showed you before. And %M just stands for month. And the output is a string output. And the output column is month. And after this, you're going to be using the one of the transform tools, which is the cross tab feature. So as you can see here, with the data set, it's a long table, meaning now if you want to study SKU wise, in this case, for instance, we're going to study based on segments. So we want supplies here, technology, and so on. And we want month in columns. That's a wide table, not long. And right now it's long table, meaning all of the dates are laid out horizontally. Now we want them as columns. Right now they are rows, you want to transform them into columns. So for that, if you can look at the logo here, so look at the symbol, right? So here it says long to wide. So basically we're going to use the cross tab, and that would let you convert or transform rows to columns. So using the cross tab, we will just pick up segment and region because we want to find out month-on-month sales figures based on segment and region. So that's your group buys. And the column headers will just be month, and the values for the new columns would be sales values. And you would be summing them up. So sum of sales figure and for segment and region. So let me run this workflow and then I can show you how the output looks like. Yeah. So this one. There's this one. Okay. So I'll run this workflow now. Yeah. So for month, if you can see here, the input was this prior to going inside the formula tool. Once you run the formula tool, you have a new column created, which is called month. And here it says 11, 6, 10, and so on, which is referenced from order date. So 11, 6, 10. So only extracts the month out of the order date. And then we transform it to this format. So we have our segment and region, and then we have months as column headers. Yeah. And then we have summed up sales for these two categories and for the month of January, February, and so on. And that's available in our browse button as well. So depending on how you want data to look like, you can use either the cross tab or transpose button. So the transpose button basically converts a wide table, like the example right now, this is a wide table. And if you want it horizontally back again, I mean, you want it laid out vertically. So you want to convert columns to rows, you'd use transpose. If you want to convert rows to columns, you'd use a cross tab. So just remember this as a thumb rule. And this will actually come in very, very handy for your data analytics. And a lot of times you might have to prepare reports or maybe do some analysis based on this. And transpose and cross tab are something that you have to really understand which is used where. So hope you guys like this lecture. In the next one, we'll look at another example with the Superstore dataset. See you there. Hey everyone, welcome back. So in this lecture, we'll be looking at summary and preparation tools. So go ahead and download the sample US Superstore dataset. It's provided with the lesson below. So first, let's import the dataset. So use the import tool, the input tool, sorry. And we'll be referencing three different sheets. In this case, one is the orders sheet, the other the returns sheet, and finally people sheet. So for question number 1, we're going to find out which region had the most number of returns and who was in charge for that particular region. And we also have to calculate the refunded amount, which is basically the net sales amount. So we'll import two different sheets here. So one is the order sheet, which contains, so the order sheet basically contains order IDs and also the customers, segment, country, city, and so on and so forth. And also there's a sale amount that's given here. So if it's a refund, we need to calculate what is the lost sale, because we'll have to refund the entire sale value. So we'll be considering only the sales column and not the profit column here. So remember that. And then for returns, we're going to match it using the order ID and the status. So if it's yes, then it's a returned item. And if it's returned, then we calculate what is the lost sale for the company. So for that, we'll use a join tool. The join tool can be found here. And we'll be joining based on the common column here, which is order ID. And after that, we'll be using the summarize tool to find out. So we'll group by order ID, we'll group by region, and we'll find the sum of sales. So whichever is a returned item, that will be mapped. So here all of this is yes, right? So all of returns sheet contains the return status as yes. So whatever matches are found are basically return products. So once we get the return products, we group them by region and we group them by order ID. So this is anyway a unique ID. And then we find the sum of sales. And after that, now we know the region. We're going to now find out which person is responsible for the particular region. So we have 4 people here. And so keeping region as a common column, we'll be mapping the person in charge for each row here. And post that, we'll again group by person, count the number as well as the sum of sales. So count here would basically give you the number of instances. So in this case, that would be the frequency of returned items. And we just don't calculate the frequency, but we'll also calculate the value of sale, lost sale. So that will be calculated as sum of sales. And then finally, we have a browse button attached to it to view the result. So I'll run this workflow now, and then we can see the results. So I'll copy it out. Yeah, and I'll run this now. So as you can see here, these 2 files are inputted, and after the join, we have about 800 records which have returns. Post that, we group all of the 800 records by order ID and by region, and we find the sum of sales. Yeah. And after that, once we group them by region, we also group them by person. So in this case, it would be region and region are the common columns. So once we group them by the order ID and the region, we also get the person in charge for that particular region. And then we have the browse button here that lets you view the results. So there's about 296 records in total. And I think that was your input as well, right? 296 inputs. Yeah, that was your initial inputs as well. Yeah. And post that, we would use a summarize tool to find out the frequency as well as the value of lost sales. So as you can see here, for Anna and Riyadi, it's about 189 returns for the year, and that's about $107,000 roughly of lost sales. Yeah, so her region suffered the most amount of return orders, or in other words, highest customer dissatisfaction. So in terms of lost sales, it was close to $107,000. Okay, so the next lecture, we look at another question based on the same data set. See you there. Hey everyone, welcome back. So in this lecture, we'll be looking at how to import files into Alteryx. So as you know, Alteryx is a very versatile tool. It supports a lot of different file types such as Excel, Access Database, SPSS files, and much more. And importing files into Alteryx is simply just a drag and drop feature. It's as simple as that. So look for input output, or short for in out, and drag the input data tool onto the canvas, and then you can choose to connect it to a file or database. So go ahead and download the global superstore dataset that's provided with the lesson, and we will import that into Alteryx to learn how the file import function works. So click the down arrow, files, select file, global superstore, double click, and now you can choose which sheet you want to import into Alteryx. So you have the order sheet, the people sheet, return sheet. So let's go ahead with orders. If you want to select a range of cells that you want to import, say you want to import from A1 to A2, you can choose that. Or if it's A1 to G7, you can choose that. So it just gives you a range of options that you want to choose to import your files. So just select a sheet, click orders, and click OK. And that should now import the sheet into Alteryx. So how do you confirm that? You can see that below the input tool, you have the file name mentioned, right? Along with the sheet name as well, orders $. So table or query typically refers to a particular sheet. In this case, orders is actually a table or a sheet in this case. Next, we have this option called first row contains data. First row contains data. So in our case, the first row contains the headers. So for us, it's unchecked. Sometimes if you have data in the first row, you can check that one. And then we have start data import on line. So we can choose to import from any particular line from here. In this case, we are importing it from line number 1, but let's say you want to import from line number 5, you can do that. So let's say you want to start with 47221, this particular row ID. If I change this to 5, I'll click this again. Now see, it starts from here, 47221. The row before takes over as the header, right? So I'll reset this back now. So it's very simple, right, to import files and configure your imports as well. And then we have this preview option where you can preview the first 100 rows in the file. And you can see that we have the row ID, order ID, dates, customer names, city, state, product, category, and also the sales and profit numbers. And we have the first 100 records that you can browse and validate. So it's very simple to import files into Alteryx, and you can also experiment with other file types. I'll leave you to that one. The next set of lectures will be showing you some more complex, really cool features to import files. So I'll see you there. Hey everyone, welcome back. So in this lecture, we'll be covering on how to navigate around Alteryx. So as you can see here, I've got Alteryx installed on my system, and this is pretty much the first tab that you see once you finish your installation. So welcome to Alteryx tab that shows you a few tutorials that you can look at to understand how it works. So here, if you can see, we have this combined two spreadsheets, input and output multiple sources. So you can go through each of this. So if I click open workflow, it redirects me to a pre-designed workflow that you can look at to study how these tools work, right? If you want to run them and see, you can just run them. This gives you a brief output on different features that you have, right? So you have insights, charts that you can run, and so on and so forth. So in terms of the layout, so this is the layout of Alteryx. So we have options to choose. So you have the file option that lets you save workflows or open any recent workflows. Views let you configure the different tabs that you want. Options with more advanced options that you can configure. And then you have all of these tabs laid out here. In out gives you all the input and output. So you have browse button, date time, directory inputs, input data, text input, and so on. Preparation tab has a lot of tools that you will use during your um, work as a data scientist or a data professional. So pretty much filter, formula, multi-field formulas, multi-row formulas, record IDs, samples, select. These are some things that you would use often in Alteryx. Then you have the join tab with joins. Joins are similar to the index match feature that you have in Excel. Multiple joins where you can join multiple sheets or multiple sets of data rather. I mean, this is something that you can. It's very difficult to implement in Excel, but you can do it very easily in Alteryx. You have unions, append. You have some parse tabs which contain. So you have regex here, date time conversion, transform. This lets you like transpose data, for instance. So from white table you want to try long table, you can use transpose. Cross tab is the reverse, is the exact opposite. From long table you want to go to white table. So you can look at the image here to understand what it does. Running totals where you want to find out cumulative sums. Summarize lets you find average, sum, and count, and so on and so forth. There's a reporting that lets you generate reports. This could be charts, this could be maps, could be a lot of stuff. Spatial tools, again, this is mostly used in a lot of analytics relating to supply chain or network design, for instance, where you want to find out distances between points, nearest neighbors. This is like a clustering algorithm. So there's a ton of features in Alteryx. It can be used for data analytics, it can be used for data science, for machine learning, and so on and so forth. So I would suggest that you try some of these features out. You can look at the documentation as well for more information on what it does. You can look at, there's a very strong Alteryx community that you can go to and understand what different users are doing on Alteryx, and lets you understand the range of possibilities. So the next set of lectures, we'll be exploring some of these tools and functionalities. So I'll see you there. Hey everyone, welcome back. So in this lecture, we look at a few functions in Alteryx. It's the select function, formula function, and data cleanse function. Again, these are also very useful functions that you might have to surely know about. So as a first step, go ahead and download the building permits CSV file. It's provided with the lesson, and import it into the canvas. I'll do the same thing here with mine as well. Yeah. So we have, going through the columns, we have the permit number, block number, lot number, street name, suffix, status, number of existing stories and number of proposed stories, and the neighborhood and zip code. So what we want to do is we want to convert the stories into planned and existing into a double. A double is nothing but a numeric value. So right now it's displaying as a string. So you can see here, it's already double, so it's fine. But just in case, if you want to convert any data type from one form to the other, you would use a select tool. So select tool has three actually very important things. One, you can reorder the columns based on however you want it. That's one. So I can push this down, for instance. You can move it up. That's one. You can change the data type. So I can convert permit number to be double. It will change automatically. I can rename them and assign a new column name. That'll still work. So, and also you can choose which columns to display or which ones you don't want to display. So let's say deselect these, then I can deselect them as well, and they won't display in the output side. So select is very, very versatile that way. And yeah, so it's best to understand how it functions. Okay, so as a next step, you'd use a cleanse tool. The cleanse tool is often used to remove nulls. So in this case, we converted stories to a double first. There could also be some null values. So I think if you go through the data set, you should see some null values. Yeah, number of proposed stories are null here, and so on. So we can convert the nulls to be 0. And then we are creating a new column. It's called address column. So if you had gone through the data set, again, we had block number, lot number. All of these are address constituents, but they're all separate. So you want to combine all of this together and show it up as address. So address is block, plus is used for concatenation, so concatenating or joining two different fields. This is, again, I would say this is deliberately done so that it fits the address formatting. Then we have the lot coming in as one of the inputs. Again, a comma, street number, then some space. So I've indicated space by using a single inverted comma and giving us gap between the two. Street name, again the same thing, gap, street suffix, a comma, neighborhood analysis boundaries. So I think that gives you the neighborhood. And finally, you have the zip code and a hyphen and a zip code. And then we remove unnecessary columns using the select tool. And finally, we have the browse button. I'll run this workflow and then we can see the results. Yeah. So we can see here we have combined. So we have converted all of the nulls first to 0. So there are 0, 0, 0, 0, 2. Next, we have combined the address, all of the columns and address into one single new column called address. And some examples are here. So for instance, in the first case, 4789 by 14, 1465. From here, street name, street suffix, street name, street suffix, comma, neighborhood name, and finally zip code 94124. So we followed this format. And now you select tool to remove unnecessary columns, and then you have the browse button that gives you whatever is required for analysis. So hope you guys like this lesson. See you in the next one. Thanks. Hey everyone, welcome back. So in this lecture, we'll be covering 3 important topics. One is the unique function. Then we have the filter and multi-row formula function. So let's go one by one. So as a first step, download the EU Superstore dataset and let's go through the dataset itself. Here I need to link it to EU Superstore dataset so that the error doesn't come up on the screen. And I can just copy this here. Yeah, it should work now. Okay, so let's first try to find out. So the EU Superstore dataset, let's go through the dataset first. So we have row IDs, order ID, we have the dates, the order date and shipment date, we have the shipment mode, customer ID, customer name, segment, city, state, product ID, category, subcategory, quantity, discount, and profit. So we also have something called region here. So again, let's find out how many unique regions are available in the dataset. And so for that, we have something called a unique tool here. The unique tool is available inside a preparation tab. This is the tool, the unique tool. So once you drag it onto the canvas, you have these options that you can choose from, and you want to find out unique of region. The rest can stay as is. So if I run this workflow, I should get all of the unique values available. So there are 3 unique values, and they are central, north, and south. You don't have to worry about the other columns. They're just particular instances that got picked up, but we're running unique only on region, so we can understand that there are 3 unique regions here: central, north, and south. Now what we want to do is we want to filter out for north and apply cumulative sales and cumulative profits. So for applying cumulative sales and profits, there's something called a multi-row formula tool that we'll use for this particular exercise. So the first step, we need to filter out which regions are north and which regions are central and south. So for doing that, we need to import a filter tool. So a filter tool is available in Alteryx, and it's called exactly that. It's a filter. right? So we drag this onto the canvas, and then you provide with two options. One is so true values basically whatever satisfies the condition, and false would be those rows that don't satisfy the condition. So here we have used true to be region equal to north. You can specify that here, basic filter region equals north. You can also do a slightly more complicated way to do the same thing. So you can use a custom filter, and you can here, for instance, say region not equal to. So not equal to is used this way. So an exclamatory mark followed by the equal to sign, central. So we already know from the previous exercise that there are three major regions. One is north, central, and south. So obviously if it's not central and if it's not south, then obviously it's north. So that's what we're going to try to code here now. Region not equal to central and square bracket region not equal to south. Now this should give you fields that, or rows rather, that only contain north. Okay, this is a different way of writing the same thing. And next we have the multi-row formula. So the multi-row formula, here we're going to create a new field which is called running sales. And the way it works is, you know, sales from every row. So if you look at the data set, there's something called a sales column. So we're going to accumulate this now. So the multi-row formula would just say sales plus, so sales here stands for the active row or row 0, row -1 running sales. So the running sales column is a dynamic column, and it keeps updating itself as and when we keep going lower down the table. So it'll add the new sale value to the previous one and then show you the cumulative total. So the running sales column would contain the cumulatives for each and every row. Similarly, we'll try the same thing with profits. We consider a new column called running profits, and that just says profit plus row -1 running profits. So we want to add the previous row's cumulative profits to the active row and give you a new cumulative profit, and that's the process. So I'll run this workflow now, and then we can see the results. So as you can see here, I've used the browse button to check the algorithm. So the first row says 79, which is in line with this. The second row should say 388.90, or rather 389 plus 79, which is 468. That's correct. So it's added. And 468 plus 35 should be 503, which is the case here. 503 plus 51 is 554. So it's working fine. The same thing with running profits. 40, 0 here, so 40 again. So 16, so it's 56, 13, 69, and so on and so forth. So it works fine. So hope you guys like this lecture, and in fact these tools are very, very important, and you'd be using them a lot during your work as a data scientist, data analyst, or also just for any sort of data related work. You would still be using these tools more often than not. So make sure you understand them, and maybe just go through the lecture again to understand them better, and try out a few exercises on your own as well. Maybe you can try using filter for a different column and see how it works. So in this lecture, we look at the next set of questions on the Superstore dataset. So here we need to find out which category sells the most items in terms of volume, and also calculate its profitability margin. And we also rank all the items based on volume. So a profit margin is nothing but profit by sales. So as you know, with the Superstore dataset, we have information on sales and profit. So we'll use these two columns to calculate profit margin. And we also need to find out which product, or actually which category, sells the most in terms of volume. So category is here. So it's furniture, office supplies, technology, and so on. And volume, you can find it by looking at quantity. Yeah. So let's get started. So as a first step, we're using the summarize tool. The summarize tool here, we're grouping by category. So we take all of the categories, and then we sum quantity, we sum sales, and we sum profit. The reason why we sum all of those is we want to find out, based on those categories, what is the net profit margin for the category itself, and what is the quantity for the category itself. So that's a summarize tool. And then we applied a formula tool here to calculate net profit margin, which is profit by sales. And then we have ranked them in descending order because we want to rank them based on volume, and we've ranked quantity in descending order. So the one that sells the most comes up first, and so on and so forth. So I'll run this workflow now. I'll copy it out and we can check the results. Yeah, so we have office supplies, and in terms of quantity, it's about 22,906 items sold for the year. In terms of sales, it's about 700K US dollars. Profit is about 120K, and the profit margin is about 17.03%. Furniture comes in second in terms of volume, but if you can look at the profit margin, it's very, very low. It's 2.48%. So the company is only breaking even, more or less, with furniture. Technology is looking very promising. It's the highest in terms of sales, although in terms of quantity it's quite low, but in terms of profit margins it's also the highest. So I think it's best that the company focuses on office supplies and technology actually looks very promising. Furniture may or may not be necessarily pursued. I mean, you can also discontinue furniture because it's just barely breaking even. So these are some insights that you can draw from the Superstore dataset. In the next lecture, we look at another question. See you there. Hey everyone, welcome back. So in this lecture, we'll be looking at a new feature in Alteryx called dynamic inputs. So as the name suggests, dynamic inputs are often used to keep inputs dynamic. So how that works is, let's say we have an Excel workbook with multiple sheets. And the way these sheets work is they have the same schema. By schema, I mean they have the same number of columns, and the columns are also similarly placed in terms of relative column placing with respect to each other. They can obviously have different rows, that's fine, as long as the structure of the sheets remain the same, and if they're labeled in the same manner, at least the column names, that should work. So let's say we have sheets that are similar to each other and we want to import all of them at once. So the simple way to do that would be to use dynamic inputs. The harder way would actually be to drag input data for each sheet, refer it to that particular sheet, and keep doing it for multiple sheets. Now this is fine if it's 2-3 sheets, but let's say there's hundreds of sheets that you want to import at one go. Then this is a very manual, laborious work, and on top of that, your workflow or your workspace rather would look very shabby. So in order to prevent that, what we have here is we'll use two tools. One is a text input tool, which basically provides the names of the sheets that we want to import. So these sheets basically can have different sheet names. So we can specify the sheet name here. So as part of the lesson, you would have gotten a workbook, the Superstore workbook. Just download the workbook and they should have these sheets in them: orders 1, orders 2, and orders 3. So once you're done with that, drag the text input tool, which is available here in out as well, text input, drag it onto the canvas and change this to sheet underscore name and specify the names of the sheets that you want to import. For this lesson, we'll try to import orders 1 and orders 3 sheets. Next, we want to show to Alteryx basically how the sheets look like. And for that, we'll have to drag a sample sheet into Alteryx. So for that, click edit and then locate the particular Excel, which is in this case sample superstore.excel file, and then specify any one table or sheet. In this case, I've specified orders 1 and click OK. So Alteryx now understands how a sheet is supposed to look like, and is going to be importing other sheets that we have specified here if they are similar in schema with the first sheet. And here we specify this as well, this option, read a list of data sources, and here we specified sheet underscore name, which is the header that we gave here, sheet underscore name, and it's going to change file/table name. So we've specified 2 files here. One is orders 1 and orders 3. So it's going to iteratively loop through each of the sheets. So first is going to look at orders 1, import it into the workflow. Second is going to look at orders 3 sheet, and then again import that as well, step by step. And finally, we have a browse button that lets you see the outputs. Now let me run this workflow and then we can see the results. Yeah, it's run now and there's about 61,284 rows. Yeah, so it's basically picked up 2 sheets, orders 1 and orders 3 that we have specified. If you want to change it to some other sheet, you just have to click here and change it. That's about, it's as simple as that, right? But make sure you specify what sheets you want to enter. You want to import into Alteryx by specifying this text input here. Post this, we have about 61,284 records and we can view all of these records using the browse button. Yeah, so this is how you do dynamic inputs, and this is very useful when you want to automate this importing process. That's one use case. So hope you guys like this lesson. See you in the next one. Hey everyone, welcome back. So in this lecture, we'll be looking at directory inputs. So as the name suggests, directory inputs are basically where you would want to import files that are located in a particular folder. And we'll also be learning about another cool feature in Alteryx called batch macros. So don't let these terms confuse you too much. They're very simple to implement. So in the previous lecture, we had covered something called dynamic inputs. And the feature with dynamic inputs is that all of the files need to be of the same schema or structure. So if there are any changes in terms of like the columns, column names, for instance, it may not work. So that is a bit problematic in terms of implementation. And that's where batch macros fills the gap. So this method is very versatile and it can be pretty much implemented on a large scale as well. So let's say you have a folder containing hundreds of Excel files and you want to import them. The only way to do it is, one is by using dynamic inputs, but again, there we should be sure that the schema is the same, or you'll have to manually drag input data tools onto the workspace and then actually physically reference each file to a particular Excel and then do it. But then if you have hundreds of files, then it will look too shabby, your workspace. So in order to avoid this, we have directory inputs. So as part of the lesson, we have provided 2 files. One is the US Superstore and EU Superstore files. So go ahead and download those 2 files and save them onto a folder. After that, drag the directory tool onto the canvas and reference it to the particular folder and specify the file type. So here it's an Excel file, so specify this as XLSX. Next, attach it to a formula tool. The formula tool is available inside of preparation tab. So what it does is it's going to give you the path of the full path of the file, or the folder rather, not the folder, the file inside the folder. So here it's going to be Alteryx for beginners, write up, and then we have the file itself referenced. Finally, we have this / orders. What this refers to is the sheet inside the Excel file. So our Excel file, I think, contains 3 sheets. One is the order sheet, then the people sheet and returns sheet. And we don't want to import all of them. We just want to pick up the order sheet in all of the Excel files. So a / orders would reference only that particular sheet inside the file and nothing else. So that's your formula bar. Finally, all of this, and by the way, make sure that the formula bar saves the output as a string file, string type. Finally, all of this goes into the macro. So this is a batch macro basically. I'll also show you how to create this. It's very simple to do. And then we have the browse button that lets you see the results. So the first step, let's see how a macro is built. So I'll build a new one and show you. First, drag the input tool and reference any one file. So I'm referencing the US Superstore file and the order sheet. Yeah. Once that is imported, search for control parameter and drag it onto the canvas. Now join these two, right? Join the Q symbol with the lightning symbol, and that should throw up the update value tool. Click on file and replace a specific string. So what it's going to do is it's going to iteratively replace each time with a newer file. So the string basically has the entire path. It's going to replace that with the next one. So first time it's US Superstore, second time it's EU Superstore, and so on and so forth. So that's the process, right? Next, we have a macro output tool, and I will save it onto the input. And finally, we'll have to configure this macro. And for that, you go to View, Interface Designer, and select the settings button here, and here you should see auto configure by name, wait until all iterations are run, and this is a standard icon. So do this and yeah, hide it. Now we'll save this as a yxmc file. So I'm going to save it as macro1 and we'll run this. Yeah, it works fine. I'll save it again. Now let's use macro1 here. So I'll show you how it's done. So I'll just copy the rest of the workflow as is. I'll delete this one and I'll include the new macro. So macro insert in macro1, and let's connect it to formula and the browse button. And let's map it to a field, which is the full path string path, right? And I'll run this macro now. Let's see how it, yeah, it's imported all of the files and you can view it in the browse button. Yeah, so it's integrated both the files. So it's integrated both the orders sheet in US and EU Superstore and is given as a single output. Now you can save this onto another Excel if you wanted to. And that's how you basically automate input in Alteryx. It's very simple, one-click solution to do that. So hope you guys like this lesson. See you in the next one. Hey everyone, welcome back. So in this lecture, we look at two questions. One is, so the first part is we find out which category or subcategory rather was the most heavily promoted. And this is based on value of discounts. So if you remember, the Superstore dataset had a discounts column as well. So sales, and you have discount here, and then you have the profit, right? So we'll be looking at discounts here in order to look at promotions. So we want to find out which subcategory was promoted the most in terms of discounts. So again, we'll use a formula tab here. So which is discount here is given as a percentage. So we want to find the value of discount. So we multiply the percentage into the sale value, and that'll give you just the discount amount. That's discount into sales. And then after that, we group by subcategory and also by sum of sales, sum of discounts, sorry. And then we're going to reorganize them based on descending order. So the ones with the category with the most discounts would feature on the top. And you just got a browse button to see the results. I'll copy this out and we can go through this. Run the code now. Yeah. So binders were some of the most discounted items, about $567, followed by phones, furnishings, chairs, and paper. So that's the order. Yeah. And finally, we look at the top customers using a tile function. So the tile function is something new that we haven't covered much in this series. So the tile function is available with the preparation tab. So I'll quickly show you some of its features. So the tile method has 5 features here. One is equal sum. So equal sum is basically when you have a group of records and you want to classify them into smaller categories based on equal sum. So they all sum up to be the same value. So it'll do that. That's equal sum method. Equal records is when the number of records are the same across. So you have 20 observations and you want to create 5 tiles, then it would have, each tile would have 4 records. That's equal records. Smart tile basically builds like a normal distribution sort of data, and it classifies them into low, medium, high. So medium is more like average, above average, high, those kind of categorizations. And manual is where you specify manually. So you want to like bucket observations into, say, let's say for instance you have 100, 200, and 300, and you want to bucket them into, say, less than 200 and greater than 200. You can specify that in manual. So those are different options available with tile. So in this case, you want to filter for high sales, right? So we're going to use the smart tile. So smart tile would automatically classify them into low, average, above average, high, and so on and so forth. So again, we'll take the Superstore dataset. We will group by customer name because we want to find out the top customers, and then use the tile and set it to smart tile, and sum of sales because we want to group them based on sales values. And then we output the name column. So we're going to create multiple columns, and these columns would be labeled based on the sales values, right? I mean, if it falls in the lower category, then it would be low, above average, and so on. And then we have a cross tab here. So and here we're going to convert the rows into columns, into a white table. And finally, we want to have, we don't want to have null values, so we eliminate them using the filter option. And finally, study the results. I'll run this workflow and then we'll look at the results. Yeah. So again, the data set is first grouped based on customer name and sum of sales. And then we have the tiles, and we have the tile numbering and the name of the smart tile. So we have high, above average, some below average, and some of them are low, extremely low, and so on. So that's the classification that it has built. So those are the numbers. So average would be 0, -1 would be below average, +1 would be above average. So those are the different gradations that it is given to data. And then it's also given sequence numbers, so which of them follow on the top. So if you look at tile number 2, this seems to be the highest, right? So for high and tile 2, Sean Miller is number 1, and followed closely by Tamara Chand, who's also high, but it's number 2. So it automatically prioritizes for each group. It prioritizes the top customers in each of them, each segment. Now again, we are classifying them in white table format. So you have the grouping based on the smart tile names rather, and you also have the sum of sales. And we want to just study the high, and we have eliminated everything that is. So we want to eliminate records that are not null for high. So these are all the high customers. And finally, we use a select tool and eliminate all the other unnecessary columns and just have customer and high. And these are your list of customers for high. There are no particular order. But as we had seen earlier, Sean Miller seems to be the highest in terms of revenue for the company. So hope you guys like this lecture. And if you really like the course and you found it helpful, do recommend it to your friends and family.